Okay, so in this video, I'm going to introduce you another formula for area of triangle. Okay, so the focus will be on in this section, there will be three formulas. So we will talk about area of triangle first. Okay, this area of triangle, so far in primary school, we have learned that area of triangle is half time base, sum side. And the requirement will be these two will need to be perpendicular to each other. Okay, so we are very used to half time base, sum side. And the condition for half time base sum height to work will be a 90-degree. Okay, so it's like your sec2 trigo. You need a 90-degree so that your sec2 trigo will work. And you also need a 90-degree for Pythagoras theorem to work. So if let's say in a situation of no 90-degree, will you still be able to find the area? So this is the alternative formula. So let me go into the alternative formula. Before I go into the that formula for area of triangle, okay, let me show you the notation again. So capital letter will stand for the angle. And small letter will stand for the length. So opposite the angle A, you will have length A. Opposite the angle B, you will have length B. Opposite the angle C, you will have length C. Okay, so let's just recap the notation first. Okay, if you look here, right, the formula says half AB sine C. So the formula area of triangle, half AB sine C. So what is the understanding about this formula? So it will be half times A times B times sine C. So notice something about the angle. The angle is actually in between the two lengths. So you take a careful look. I'm using angle C. If I'm using angle C, I'm using the two lengths that wrap the angle. So in such a case, right, there's actually a name for this. C is known as a included angle. That means it's actually included in the two lengths. So generically, you will see here people say half AB sine C. So this formula will be extended into radian mode subsequently as well. So later, next time we'll talk about radian mode. So at the moment, you will need to use the angle that's in between the two lengths, and as such, C is called the included angle. So if you look again, there is another formula that I put here, half BC sine A. So why do I put a half BC sine A? Half times B times sine, half times B times C times sine A. So why do I choose that? So you take a careful look. This is angle A. If I'm using angle A, the side that is relevant will be B and C. So B and C wrap the angle, or rather A is in between the two lengths. So A is the included angle. So the condition for this formula will be you must use an included angle. You cannot be using any two sides or any random angle in the triangle. So you specifically got to use the angle that's in between the two lengths. So in the last one I mentioned here, AC sine B, half times A times C times sine B. So again, you look at the angle B. Angle B is wrapped by A and C. So angle B is wrapped by A and C. So B is in between A and C. So B is the included angle. So in a triangle, you will not be labeling like A, B, C, or that. So you just look for angle. You just look for two lengths. You can use your hand to think about the two lengths and the angle that's in between the two lengths. So when you're using this formula, you will be expected to execute this formula to find area of the opposite. So sometimes the question will give you the area, and subsequently you got to find either the missing length or the missing angle. So later on, I will show you in the example. So as a very quick example, we take a simple equilateral triangle. So I'm sure you know what is an equilateral triangle. So if let's say you know this is an equilateral triangle of sides 3 centimeter. So will you be able to find the area? Yeah, I will be able to find the area because I know that in an equilateral triangle, I got a lot of 60 degree. So I can find the area of a triangle using this formula. So if let's say I'm going to use this new formula that you learn, okay, I will use any two sides. Okay, all the sides are the same, so I can use the two sides, 3 centimeter, 3 centimeter, and 60 is in between the 2 centimeter, 3 centimeter. So you'll be half times 3 times 3 times sine 60. And then you punch calculator directly. So most probably sometimes you're not going to get a very nice answer. So when you don't get a very nice answer, you round it off to the 3SF answer. Okay, so a very simple example on an equilateral triangle. So is it a must to use half AB sine C for this for just this equilateral triangle? Can I go back to the half done base sum height? Actually, you still can go back to your half done base sum height for this one because the property is such that you will cut into half. It will cut at 90 degree into half. So in fact, you can do the longer way if you want to. Of course, we don't recommend. So if let's say you can choose to find the height. You can choose to find the height. Okay, maybe I use back the H. So I can find the height by using a Pythagoras theorem. So if I use the height, if I do it, if I find the perpendicular height using the Pythagoras theorem, I can still go back to half AB, half done base sum height. Eventually, the answer will be the same as half AB sine C. So because half AB sine C and half done base sum height actually give you the same value, there will be times that we will use area, we will use half done base sum height in order to find the shortest distance in a triangle. Okay, so you will see this kind of question. So it's the area method. So comparing half AB sine C. Okay, so maybe I write here. So sometimes, right, there will be questions that require you to compare half AB sine C with half done base sum height. Because both formula measure area of triangle. So whether I use half done base sum height or whether I use half AB sine C, they should be the same value. So because of this, there are some questions that play with this idea for you to find the perpendicular height. Okay, so you will see it coming in the subsequent question. So this is just an introduction of an alternative formula to half done base sum height.